So now we'll continue with the linked list. We will do the remove method. So we'll go back to the linked list class. So I've decided that we won't be debugging actually. Because it just takes too long, and I have tons of other data structures to do. So if you want to learn how to debug, see the link stacks, the dropout stacks, the queues, the link queue, the rake queue, the circular queue, or the link deck. I think I debug all of those so you can see that, because it just takes too long to debug all the methods. We don't really need to walk through them. We've walked through them before. This is basically the same as the link stack, maybe just a little harder. It's like the link queue. It's exactly the same. So if we have time, we'll try, but at this time, probably not. I've showed you guys how to debug, so it's not too hard. So we're just going to test it in main. So first we'll start with the remove first method. So we'll have, we'll put this, or we're going to put this, we'll put this right here under the constructor. So we'll have public t remove first. Public t remove first throws empty collection exception. One sec, let me just wipe my sunglasses. Got steam on them. I actually code with sunglasses. The reason why is because looking at the bright lights for like over 8 hours a day will contribute to headaches. So a good tip is to try sunglasses. I'm using the ones I got from laser eye surgery. I don't know if it's polarized or not, but I might get some other ones to try in the future. I don't think these are polarized, but maybe polarized might be better. But you can turn the brightness up if it's too dark, but I think overall it does help. It saves you headaches, because I noticed when I used to not use sunglasses every day, almost, not every day, but every few days I'd have a headache. But now I don't get them anymore. So you can try that if you want. So we'll put if is empty. Then we'll throw a new exception. Throw a new empty collection exception. I've tried to get other people to try the sunglasses, and they're like, nah, I'm okay. It's like, well, I was just trying to help. So linear node of type t, temp points to head. If temp dot get next, we'll say here. I will say if temp dot get next is equal to null. So let's just take a step back for a sec. We have public t remove first throws empty collection exception. If it's empty, we're going to throw that. We know about that. So here we're going to create an object reference variable temp. We're going to point it to head. Then we're going to say if temp dot get next equals to null. So if there's only one element in the list, basically, I think that's what it's saying. Then we're going to say head points to head dot get next. Tail points to tail dot get next. So we're going to say head point to the next. Basically, it's going to be pointing to null if there's only one, because if there's only one element in the list currently, and temp points to head, and if temp's pointing to head and temp dot get next is equal to null, which means that there's no element after head. then head is going to basically be pointing to null. So I think we could have set pointed to null. And then we're going to decrement count because we're removing something by pointing it to null. I think there could have been a better way to do this. Excuse me, this might be the book method. There might be one method or two that they've given us. But perhaps we could have set a pointer to it and then set it to null. If I see the opportunity, I'll try to point it out. So here we'll do mod count ++ and then return temp.getElement because it returns type T. You can make it void if you want, but we'll return the element being removed. So if we don't really need to do it because, well, it's sitting on this, it's still in memory somewhere until it's eligible for garbage collection, but it's going to basically just, that node that we're removing is just going to be not attached to the linked list. But I think I've done it before. At this time I'm not seeing a direct way to delete it. We could have maybe said, oh, you know what, I think I know what to do. To do that we need to use the best way to do that is to set the element or the next to null. It might sound a little tricky. I have it written down somewhere. It might even be here. To nullify, I just called it to nullify. Okay, yeah, I have it here, so we could just put use set next or set element to nullify. So nullify, I don't know if it's a real word, probably not, just means to set something to null. So if we could create an object reference variable here, like a temp2, and point it to temp maybe, something like that, and then we could set, well, we can't set its next if there's only one element, but we could set perhaps its element to null. Let's see if temp.getNext points to null. So let's say, I guess I will have to do this if we're not debugging. So if there's 5, let's just say there's only 5 in the list. That's our list, 5. So temp's pointing, so head's pointing to 5 and temp's pointing to head, which is pointing to 5. Oh yeah, I still have to do a bunch of diagrams. So if temp.getNext, so if temp points to head and head, if temp points to head and head points to 5, and if temp.getNext, well, temp.getNext is null, equals to null, then head points to head.getNext. So this is kind of like a set next. But what we also could have done was we could have created a temp2 points to head. So temp, we could have maybe set temp.setElement. We won't be able to set the next, but here we're kind of setting, we're kind of doing that here. We're kind of setting head to null here. We are setting it to null. So what else could we do here? Temp points to head. If temp.getNext is equal to null, so we're just trying to set the one element, right? So temp. Do we ever set temp to null? We didn't. So let me just see where we are here. We're on remove first. We could maybe set if temp.getNext is equal to null, then maybe we could add some stuff here after. we'll come back. So if temp.getNext, this works right now. This works, but could we make it better? Maybe we could. More clear at least. So if temp.getNext is equal to null, then head points to head.next, which is really setting it to null. Tail points to tail.getNext, which is also setting it to null. We could have really just pointed head to null and tail to null, I believe. Count minus minus mod count, return temp.getElement. So if there's more than one element in the list, then we'll say head points to head.getNext. Count minus minus. I think this is a book way. Mod count plus plus. They gave like one method for this class, and they said figure out the rest on your own. So return temp.getElement. So what we could have done here is maybe we could have said here, we could have set temp points to null. And perhaps we could have said temp dot set element to null. That might have worked. Let's just say we added that. We added that. Here we could have also set temp to null here. Okay, no, we couldn't, because we're returning temp.getElement. Aha, okay. That's silly. So I guess we don't need to do that because it's a type T. If it was a void, that would have worked fine. Because we could have set everything to null. We could have done the same thing here. Temp set element to null, temp endpoint temp to null. But we were unable to do this because we want to return the element being set to null. So if we see the opportunity, we didn't need to do this, sorry, this was supposed to be added. So if we see the opportunity in the future to nullify stuff, to free up space, we'll try to. So after that, that should be fine. Usually removing the head is usually the easiest. So we'll do the next one now. So we'll do remove last. Actually, it might be easy. Actually, no, it won't be that easy because we don't have a previous reference. If we did, it would be easier because we could just traverse backwards, but we can't, so it's going to be a O of N operation, I think. So public T, remove last, throws empty collection exception. That's it. So if is empty, we'll throw a new empty collection exception. Linked list. Excuse me. Let's see here. So we have remove last, throws empty collection exception. If is empty, throw new empty collection exception, linked list. So we're going to set a variable named tResult, point to tail.getElement. Then linear node of type T. Temp points to head. Okay, this one's a little confusing because we have one pointing to 1 and another one pointing to, you'll see. So we have a linear node of type T. Temp2 points to temp2 points to temp, so it's a little confusing. Temp's pointing to head and temps2 points to temp. I forgot why I did that, so we'll see. So the condition I used here was falling asleep here. So if count is equal to 1, but we could have said if head.next points to null, or if head points to tail, something like that. We could have used any kind of condition here that worked, but this one worked, so it's fine. So we'll just set head points to tail, which points to null. That's just a fast way to do it. Instead of doing head points to null and tail points to null on 2 lines, you can just do everything on 1 line. So we're saying head points to tail and tail points to null. So head is directly pointing to null. Think of an arrow like this. Tail's pointing to null like that, and head's pointing to null like that, because it's pointing to tail, which is pointing to null. Or you can think of a tail pointing to null here, the equal sign. Tail points to null, and head points to tail. So where does tail point? Tail points to null. That's how I remember it. I don't know if that's completely accurate, but it works. It should be accurate though. If temp points to temp2, or just say same thing here. So temp points to temp2 and temp2 points to null. So temp2 points to null, temp points to temp2. They all point to null. So if count is equal to 1, then that means there's only one object in the list. Therefore, we're going to set head point to null, tail points to null, temp points to null, temp2 points to null. We're going to decrement. We could have actually found it, and perhaps we could have found it using an extra object reference variable. And we could have said, okay, actually, because again, we can't do that here because we're doing t. If we weren't doing t, we're doing void, then we could do that again as above. But because we actually want to return the element that's hanging out on the side of the list, that's what's going to happen. I think maybe to be more efficient, if this was a code managing our app, perhaps we could have sped it up by using void, and then we could have maybe set everything to null, set elements, set next to null, and then equal it to null at the end, the object reference variable itself. Then maybe it would have freed up more space. You'd have to test it. So here we'll say count minus minus, then we'll say mod count minus minus, then return result. So we're just decrementing our counters and returning result. That's why we didn't set everything to null, because we're returning it. But perhaps we could. Actually, because we already have a pointer. Do we have a pointer here? Remove first. We could have changed it actually. We could have said, we can try that at the end. We'll try to remember to come back. We can do what we did here, set a t result pointing to head.getElement. Then here, perhaps we could have tried to nullify it. So we'll come back. We'll put we'll try to remember. So we have a little bit more to do here. So if count is not equal to 1, so if count is well, it's not going to be 0 because that would mean it's empty. It's not going to be 1 because we have it that it's 1. So it's if count is greater than 1, then we're going to say you have to try to think of every possibility when you create apps. That's where testing comes along. Sometimes you don't get them right away. So while temp.getNext is not equal to null, So while temp, which is pointing to head, dot get next is not equal to null, temp points to temp dot get next. So it's going to remove the last element as long as the last element. So it's going to keep searching. It's going to traverse through the list until it finds that the last element's next reference is null. Then it's going to say, okay, we found the last reference or the last node. Then we're going to say, well, temp 2.get next is not equal to temp. So we're going to compare memory locations. What am I missing something here? Okay, so we'll say temp 2 points to temp 2.get next. I forgot why I did that. We'll find out in a sec. Okay, I understand. Because we're gonna remove the last element. We're gonna set temp to point to the last element. Then we're gonna have to remove that one. Then we're gonna have to set a temp 2 to point to the one before that, because we're gonna have to set temp 2 to the new tail. We're gonna move tail from temp to temp 2. Basically, we're gonna shift the tails back. That way we can properly get rid of the element. So we're gonna say tail points to temp 2. Then we'll say temp 2 dot set next to null. Okay, so here we are nullifying. But we didn't do it in this one. So we'll try to do it up there. Because we're setting, hey, temp 2, set your next, that one that we removed, set it to null. Because we already have a result pointing to it. So that's the proper way to do it. I think I've tried to do that before, and perhaps we didn't get it right because I probably forgot. Then I was coding and I was like, oh yeah, you got to use set next or set element, then set it to null at the end. So that's the trick when working with, if you have setters, you have to set your next and set your elements to null to nullify it properly, then set the temp2 to null at the end. So here we'll do count minus minus. It's all trial and error, right? So mod count plus plus. Sometimes you won't know what to do right away, and once you test different things, you're like, okay, I'll try this. Well, that didn't work. I'll try this. That didn't work. Then, like after 10 tries, it's like, hey, this works. Then sometimes it works like that. Like I worked on codes that like take like hours, and you can't figure it out, and then all of a sudden it just clicks. So that probably will happen to you. So if temp points to null, then temp 2 points to null. So after we've nullified it, we're going to set them to point to null to make them eligible for garbage collection. Then we'll return result. So that should be all. We're missing a bracket. No, we're not. It's down here. So that should work. Can we nullify this now? So remove last, if is empty, throw the exception, set a pointer to the tail.get element what we're removing, temp points to head, temp 2 points to temp. So if there's only one element in the list, head points to tail points to null. So if there's only one element in the list, I'm thinking if we should create an object reference in here or out here. Or do we even need to do that? Because we already have some. So we're saying head point to tail points to null. So temp points to head. Before that, could we say temp dot set element, set tail dot set element to null? Can we do that? Would it even? We'll just put test. So then we'll do a temp. We'll say temp dot set its next to null. I think maybe it already is doing that. Perhaps because we're setting head and tail to null. But that does work. There's nothing wrong with doing that, I think, but then what I'm thinking is that we don't have any pointer to tail. So we could do the same thing for tail. We could create a pointer somewhere, maybe in here locally. Then we could maybe set the same things to null. We can just maybe come back and test it, because perhaps we're giving too many lines of code. We really just want the element to disappear, so maybe we'll just we'll come back and test it. We'll just say come back and test, or just say back test. We'll come back and test it, nullifying. We only really have to do it for these three methods. That's it. Whereas the first one, we didn't do anything because of the return temp dot get element. We'll come back and try it. That should be right. Just checking it over real quick. Count points to one. Count is equal to 1. Head points to tail points to null. Temp points to temp 2 points to null. Count minus minus. Mark count plus plus minus minus. I mean return result. Tail points to temp 2 dot set next to null. That isn't nullifying right there. That is nullifying. Because I'm thinking if we're setting the whole thing to null, are we not really setting the element? Right now it works, but maybe there's still some things that are hanging around the list, basically. Like there might be some objects beside the list that aren't connected. So we might have to look for those and try to delete them. But right now it's okay. It looks fine. And we'll do remove. We're gonna have a target or an element to remove. We're gonna use the same conditions as before. So here we'll try it now. So we'll do public T. Public T remove. I've tested it. This way does work. I believe I've already tested this. I'm just thinking we should maybe set those extra objects lying around to null just to free up space. But it does require more lines of code. So we'll say here if is empty. And we'll throw a new empty collection exception. Linked list as a string. Then here we'll say if count is equal to 1 again. Then we'll say tResult points to head.getElement. So we're creating a pointer to the first node. Then we're setting head to point to tail to point to null. I feel like that element is still just lying there. So perhaps it would be a good idea to maybe set a pointer to it. Because above here we did the same thing. If count is equal to 1, we already have our tResult pointing to tail.getElement head. Points to tail, points to null. So if there's only 1 in the list, then we're just setting head and tail pointing to null. Temp2, those object reference variables just get set to null. I feel like that element is still lying there somewhere. So why don't we create an object reference variable in here, and we'll set that up. We'll say linear node of type T. We'll just call it like delete or destroy. Points to, we could call it nullify, whatever. Yeah, we just call it nullify. Whoops. Nullify points to head. So why don't we say nullify dot set element. Could we use temp for this? Yeah, I think we could just use temp. Yeah, that's fine. We could just use temp. So you could say we'll delete. Actually, we won't delete those. We'll say temp dot set. We're gonna do two things here. We're gonna set its next reference to null. So we'll set its next. Hopefully this will get rid of that element. So set next to null. And then we'll say, okay, set your element to null. So we got the head done. Then we'll say we added these two. I'll just say test. So if we're setting its next, we're setting heads dot next to null, and we're setting heads element to null, then we should be deleting that element from the memory. Then we're saying, okay, head and tail point to null, and now temp and temp2 point to null. We still have that tail element lying around. So we could say, we could take temp2 maybe and point it to tail. Or we could just create a new one. But why not just use temp2? We already have one. So temp2 points to tail. Then we'll say temp2 dot set next to null. Then we'll say temp2.set element to null. And we'll say we added that too. And if we had a previous reference, this would be this times 2, because we have to set the heads and the tails previous to null. Then we really set head and tail to null. The reference itself though, right? Because all it is really is, look, this linked list, no it's not. Where's our linked? Okay, actually this is linked list, so all it is, look, it's just an object reference variable, just like here, just like temp. But we're pointing it to head, so then all we're really doing is just setting that object reference to null. It's not like we have a sentinel node, like as we were discussing before. When we create a node here, we're instantiating a node. It's not like we're setting that node to null by setting it equal to null, right? We're not setting that whole thing to null because it's an object reference variable, so that can be a little confusing. So that's why we're going to test that here. Where did we say we were just testing that? Here. So we were testing that here. We set everything to null. So set next temp, set next element to null, then temp2 points to null, tail, sorry, then temp2 dot set next to null, then temp, should I set temp2 here? Yeah, temp2 dot set element to null, then head points to tail points to null, then temp points to temp2 points to null. Don't forget to delete the object references. So we'll try that. And we should probably do that down here too. So I might have to delete that. So the thing is, we won't be doing tail though if there's more than one element. So that's probably a good thing. So here we're just, if there's only one element in the list, right? If count equals to 1, that means there's only one element in the list. That means we're going to remove that one element, and at this point head and tail are both equal to that one element. So if it's 5, then they're both equal to 5. So temp's going to set its next, which is pointing to head, to null, then it set its element to null. Temp2 is going to point to tail. Temp2 set its next to null. Temp2 set its element to null. We have to delete everything because it's only one element. In this part, we're only going to have to delete the tail because head's still going to have its own reference. So tail is going to point to temp2. That means, okay, temp2 is going to set its next to null. We're going to say temp2. I feel like it maybe should have been temp. Let's just remove last, right? Did I make a typo? Remove last. Okay, so yeah, I think that was a typo. No. Oh, actually no, that's correct because temp2 is a one before temp. Think of temp in front of temp2, and we're setting temp2 dot set your next to null. So that's correct. So that means we would say temp is what we're really deleting. Is we're going to say temp dot set your next to null as well, because we don't want your next connecting to anything or linking to anything. Then we're going to say temp dot set your element to null. We only have to do one because we're just working with the tail. So tail points to temp2. That should be correct. So I'll just say test, oops. So I guess we will be doing a little bit of debugging. I don't think we need to do it for everyone. But if it works, maybe we'll be keen on doing that. So we'll just see if it actually deletes that element, or if we can even still find that element, because sometimes the debugger won't even show it. That should be good. So where were we? We're here in remove. Sorry for jumping around. I think I just realized that like there's still an element floating around, so I'm trying to get rid of it. Trying to delete it from the memory. So public T remove T element. I think it would have been illegible for garbage collection anyways, but this is a good way just to spot it. Just extra practice if we can find it. So if as empty, we'll throw an exception. If count is equal to 1, we'll set T result to point to head.getElement, head to point to tail to point to null. They're just object reference variables pointing to null now. Count minus minus, mod count plus plus, return result. So again, we could do the same thing as above, but we'll just see if it works, and we'll just work with this for now. If this method works and it actually is doing what we want it to do, then we'll come back and change this. This one and that one. The one above, this one, remove first. So we're returning result here if count is equal to 1. On a remove, you'll have to increment mod count because it's just a mod. It's not tracking anything. It's not removing anything. I mean, if it's just saying that we modified the code. So we'll try to explain those later. So return result. So you can check if element is head or tail solely also. Sorry, we can check if head or tail. We can check if element is head or tail solely, and above we checked if it's head. Okay, so above here we checked if it's just I wrote a note for myself. Sometimes I can't understand what I wrote, but we're just saying this just checks if head is, if it's just the head element, basically. That's what we said. We can use different conditions, whatever works. So here we'll say if. So the element here is really target, so we maybe could have changed it to target. But we'll say if tail dot get element dot equals, so it's a method chain, element. So if tail dot get element equals to the element that we're removing, then we'll say T result points to tail dot get element. So set a pointer to what we're removing. Then we'll call remove last. Okay, yeah, so I did create this method. It did end up working, thankfully. So you can do that. You can call methods in a method. This is a remove last. So we're gonna have to see if that works first of all. Then we'll do that. So it may just change everything here as well. It's kind of tricky what's happening here, but we'll try to work with it. then return result. Then here we'll have a linear node. Whoops. Linear node of type T, 10 points to head. So here we'll do the same condition that we used last time. So while not, we're going to need two brackets, I think, two parentheses. So while not temp.getElement, what would happen there? While not temp.getElement element. Oh, come on. Temp.getElement dot equals, so we're using method chain here again. I might have not mentioned that earlier. Dot equals element. Oh, what happened there? Dot equals. I think I might have messed something up with my keyboard. So while not temp.getElement dot equals element, and temp.getNext does not equal null, so while temp.getElement.equals, so while temp.getElement does not equal element, and temp.getNext does not equal to null, so we've gone through that loop. We're just traversing again. So we're looking for it, right? Temp.getNext. Temp points to temp.getNext. Then here again we'll check if we found it. So if temp.getElement dot equals, oh come on, dot equals element, so if temp.getElement dot equals element, so method chaining again, then we'll have T result points to temp.getElement. I think we could have missed, excuse me, falling asleep again. Actually, I was gonna think we could have maybe put this pointer to the temp.getElement above here, but at this point, it would have changed if it was different. So we'll just do it that way. Then temp.setElement, temp.set element to null, temp.setElement to null, count minus minus mod count plus plus, return result. Temp.setElement to null, count minus minus mod count plus plus, return result. Should be correct. Here we're nullifying. Here we're nullifying. Temp points to the element we're going to remove, I think. It's a bit of a long one, then we'll have just the last else. System dot out dot print line object not located, or element, whatever. We'll do object, why not? Then return null. So that's it. So we'll test if that one did work. We're actually about done here, except we just have one long one and one small method to do. Then we also have the doubly linked list to do later on, and maybe a sentinel doubly. I don't think I'll do a singly doubly. Just need one of them and you can figure out the other one. And also you can do ones without tail and with tail, so you could be doing up to 10 different lists here. So we'll just try to get like 4 of them. I think I might do a singly linked list without a tail. Maybe, maybe not. Just a few, at least a few methods. Maybe I'll do it later on, just for practice, because we still have trees and graphs. What else we have? Search trees, graphs. Might be it. Oh, we have hash, which is just an array with a code, with a key code, basically. So maybe after I do those, then we'll maybe come back and do some more list implementations. I'll be putting those up in the next few weeks, all of them. Tree's a little complicated because it has a node within a node. It has a root. Then each root has like a left child, a right child, and its own root. So I'll explain all that later. But we'll get it. Let's just do this method, then we'll test the nullifying, see if it's working. Then we may change this one and that one. And then that's it. We just have the add method to do in the ordered list. So we'll go down here below, actually maybe above first, we'll say public boolean contains. Takes a T target. Throws empty collection exception. I do not want my brackets like that. If is empty. Then we'll say throw a new empty collection. Linked list as a string. Did I spell something wrong? Yep. Okay, no, that's definitely not what I wanted. Then we'll say a linear node of type T, 10 points to head. Linear node of type T points, 10 points ahead. Then we're going to use that's whoops, not in the if, outside the if. Then we're gonna use that condition that we used while not temp.get equals or whatever. So while, add a bracket, put an exclamation, while not temp.get element. So if you have a good condition, you can keep using it over and over again. So while temp.get element, dot equals target, then at temp dot get next does not equal to null. Temp points to temp dot get next. Then here we'll check if we got it. So we'll say if temp dot get element dot equals target. So if temp dot get element dot equals target, that means we found it. Then we'll say system dot out dot print line. Target plus the string found, or located, whatever. And we'll return true. I just did it that way. You could return, you could have set it up to like return print this if it's true and return print that if it's false. This way works fine. Works easy for me. So system.out.println. Then write not located as a string. Then return false. That should be it. So if is empty, throw the exception, linear node, 10 points ahead. Well, temp.get element dot equals target and temp.get next does not equal to null. 10 points to temp.get next. If temp.get element dot equals our target, print we found it, return true. If not, print we didn't find it, return false. That's it. We'll just have one more. We're going to have to create a new class. Why do I have an FX folder here? So we'll right click our SRC folder, click new, so we'll have where am I looking at? Okay, we need to do ordered list, linked ordered list, that's unordered list, linked ordered. There's also an index of method I created. We'll do that in the wlink list though, just because this one's taking, we've been doing it for 2 hours now. And we still have to test and check those nullifying nodes, so we'll do linked ordered list. I can't even see that, it's so small. Like I have a big screen for this computer, and the writing's like, it's like less than 8. It's like 4. I don't know why they did it like that. Linked ordered list. I can't even change it or see it. Linked ordered list dot java. See, that's so big, but that writing's so small. It's even smaller than that. So public class linked ordered list. We'll just write that again. Public class linked ordered list of type T extends. Don't forget to extends. Extends linked list of type T implements ordered list ADT of type T. Whoops. That should be good. We just have one method, and it's the add method. Oh yeah, we have to set up our supers variables first, so we'll just say creates an empty list. We can have some doc here. We don't need to, we'll just say creates an empty list. Public linked order list. We'll call super. That sets up all our supers variables, instance data, call the constructors, everything. So I'll just write some doc here. I'll say this is my singly linked list. Okay, so adds the specified element to this list at the location actually we don't need that, that's fine. I'll just explain it. So what we will do is basically there's three possibilities here. So we're going to say if the element is an object of comparable, we'll throw a new non-comparable element exception. Okay, I think I know what to do here. So we'll say if not, if element, sorry, we didn't even create the method yet, okay. So we'll say public void add t element. If not, then element instance of comparable. So if element is not an instance of comparable, so it has to be a comparable object for it to work. Then we're going to throw new non-comparable we might have to create that method. Throw non-comparable element exception linked as a string ordered list. Yeah, I might have to do this in another part after. Maybe, maybe not. Did we already create that one? Non-comparable. Okay, we did. So copy that if you don't have it, it's just an exception class. Where were we here? So throw a new non-comparable element exception. So of course we're going to have to instantiate. So we'll say we'll instantiate linear node. So we'll say, how do we do that? We say linear node of type D. Node points a new linear node of type T. Don't forget to tag on element. So linear node of type T node points a new linear node of type T element. So that's how we instantiate a node. We've seen it a bunch of times. Linear node of type T node points a new linear node of type T then pass an element as a parameter. Then we're going to have to create another linear node here, object reference variable, linear node of type t temp, points to head, and linear node of type t temp2 points to null. Then we'll say if is empty, so we're going to say okay, if our order list is empty, then set head to point to node and tail to point to node. I feel like I didn't increment count here. Okay, that might have been my bad. We have a count, of course. Count add mod count, so we're going to say count plus plus, mod count plus plus. Done. Oh wait, did we do that at the end perhaps? Yep, we did, so we don't need to do that. So here we'll say else if. Else if. We're going to have to do some casting here. So we're going to say else if we're going to need tons of brackets here, so let's just do this. We'll say element. We'll actually maybe we should just cast it right now. We'll just say 1 bracket, 2 bracket, 3 brackets. So in the third bracket we'll say comparable of type T. I think there's a way to do this. You could just cast them all at the top, but it's not really that big of a deal. We'll just say add, because you can just hit Alt Shift and Enter, it'll do this for you if you're using IntelliJ. But we'll say if comparable of type T, cast that to element. So cast element to comparable of type T dot compare to head dot get element with a dot. One, two, three does not equal to 0. So if the element's the same, then it can just be put beside the element, right? It doesn't have to. So if it's equal, so we're gonna have to. Excuse me. So we're gonna have to do a less than or equal to 0, a greater than equal to 0, and a greater than 0. So here we're casting comparable of type T to element. So we're saying else if element dot compare to head dot get element is less than or equal to 0. But we're saying okay, we need to cast that. Then was that unchecked? We'll just say no dot set next to head. Head points to node. So we'll come back and test that. All it's saying if the comparable element, so if the element that we're passing in, so if it's not empty, then it's saying okay, if there's at least one element in the list, let's say there's one element and it's 5. Then we're saying, okay, if the element that we're trying to add, let's say we're trying to add 6. If element which is 5 dot, no sorry, if 6 dot compare to 5. So is 6 less than 5? It's not. So this one would get skipped. But let's say if we are adding 4, so 4 is less than 5, so if 4 dot compare to, let's say head dot get element is 5, so if 4 dot compare to 5 is less than or equal to 0, so it's either less than or the same, because if it's the same then you can just put it beside. Then we're going to say node, which is 4, set your next to point to head, which is 5, then head, now point to node, so move over to 4. So that's all that it's doing. So if it's going to be, it's either going to be the head, it's going to be the tail, or it's going to be in the middle. So if it's not the head, then it's going to be the tail. So we'll say else if. So 1 bracket, 2 bracket, 3 bracket, comparable of type T, element, dot, compare to, tail dot get element, 1, 2, 3 parentheses, is greater than or equal to 0. Tail dot set next to node, tail points to node. So if our element, let's say we have 5 in the list, we're trying to add 6. So if 6 dot compare to tail dot get element, let's say 5. So if let's say 6 is greater than or equal to 0, it's true. They're going to say tail, which is 5. Set your next to point to node, which is 6. And tail shift over to point to 6. So that's all that it's doing. Then here, if it's not the head, it's not the tail, then it's going to be in the middle. You're going to need a while loop. So we'll say while comparable of type T, again casted, to element dot whoops, okay, come on. There's no remove method in this. I mean undo operation. There is, but it's like some other weird, it's nothing that you're used to. So dot compare to temp dot get element is greater than 0. So if the element's greater than the temp dot get element, so we're going to say temp2. Do we have a temp2? Yeah, we do. Temp2 points to temp. Temp points to temp dot get next. Then we'll say node dot set next to temp. Then temp2 dot set next to node. Count plus plus after all that, and mod count plus plus. So that is it. We finished everything, and we are officially missing a bracket. And we're still missing something's happening here. What's up with this? unknown class, so it must be outside of the class. Maybe we just have it down here. No. Excuse me. I'm not sick. My nose is just I always get allergies. Actually, my nose is always stuffed almost. I have no idea why. So we have our code here, and we're missing a bracket, I think. Else. Okay, here we go. This one should be out here. No? Yes? What just happened? Yeah, I messed something up. It's one of the else ifs. So else if. Where's if? If is empty. Else if. Else if. There should have been an else here. There we go. Else. There should have been all in there. That should have been probably like that. Right? No. Yes, no, this should have been like this. That should have been like that. Perhaps that should have been like that. I think that's correct. Unless I got the indentation off. Nope, it's saying. Actually, that might be right. Perhaps that should be down here then. Should be right. Save it. And we will probably come back and test it. I'll probably take a break. I'm actually gonna go work out. I have a bunch of equipment in the garage. I used to go to the gym, but like there was always this home gym in the garage. And then I ended up buying a power cage, 810 XLT from Fitness Reality from Walmart. I ordered it online. It was like, I think I got it for like 400 something, 469. Plus the bars and the weights and all the attachments. It's like 1500 bucks, but it's really worth it. I ended up getting some because the home gym in the garage, it's like it has cables and a bunch of machines. I'm just missing like one or two little things, and I have the whole gym. Literally, it's a huge home gym. Like there's tons of stuff in there. Because gym passes are so expensive. They're like I think it's like 400 bucks a year. So why not just spend a couple of years and put it down and just buy your own stuff? But I guess that home gym itself was like 2,500 bucks. Or something like that. So I think once I get the last attachment, which is like 1,400 or something, 1,200 plus tax, and then like a bicep preacher, seated preachers, because right now I'm doing standing preachers on the bench. But if I get the seated preacher, it'll be good for a while. Then I got what else? Then I'll need because I'm starting to almost max out the weight on the home gym itself. So I think you can only add one 50-pound stack. Then I might have to start getting hammer strength machines, and those plates are expensive too. So yeah, anyways, we'll try to instantiate some objects here. So what we're gonna do is we're gonna create our main class here, public class main. We might actually come back. Public static, we'll just test some. Well, let's just see if it works first. Public static void main string array args. Haven't instantiated a main method in a while. Is that correct? Should be. And we'll say unordered list. No, sorry, we'll say linked unordered list. Hopefully Shiba will go to like $1 in a few years. So linked unordered list of type T. I'll try to do a video on that soon too, if you're watching both. So linked unordered list of, sorry, not type T. We're going to do integer here. We'll test strings as well. We'll just test with this. Let's just say list. Let's just say uList, why not? Points to new linked unordered list of type integer, and it's going to be empty. Then we'll say uList dot add to rear. We'll just click play. We probably have a mistake somewhere. That's a lot of code. Yep, we do. Okay, so abstract linked list does not override abstract method iterator in list ADT. Iterator, I don't even think I have that here. Oh, I do have the iterator. Okay, this will be another part of the video then, so we'll just comment that out. And we'll comment that out too, because we have iterators. I think the textbook provided it, so we'll have to do another video on that after. So we'll just get it working first. Main method, click play. Set previous, we're not using link deck. What is that talking about? Okay, so I'm gonna have to delete these now. Great. Because it's saying, hey, our link deck isn't working. Excuse me. So I will delete you. Hopefully it works now. Wow, it's gonna work alright. So it was added. So you know what? It's been 2.5 hours. You won't notice it, but I'm gonna take a break. Probably gonna do this later tonight, so I'll just take a little break and I'll come back.